Tausif?
Sir. Yes, sir. Is it visible?
Tausif, are you there?
Yes, sir.
Students, is my voice audible for you?
Yes.
Tausif, is the screen visible?
Yes, sir. Visible.
Is the screen completely visible?
Yes, sir.
Tausif?
Sir? Sir?
Tausif, respond. Are you there?
Yes, sir.
Tausif, your voice is not audible. Is the screen visible, Tausif? Is completely visible?
Sir.
It is audible, sir. Sir. Sir, it is audible.
Students, is my voice audible for you?
Yes, sir.
Is the board visible? Board is visible, right?
Yes, sir.
Okay. So participants are still 87 or 89. We expected 180, but still 100 people lagged. Students, yesterday we take the total attendance which was recorded in my WebEx database. The participants are only some 110 maximum. So 110 members, roll numbers, and how much time they are in the session was also seen in the database, and we just calculated and we just saved that data. So today also we just consider how many people are going to be participated. So I request all of you, if you are supposed to place your names, kindly replace your name with your roll number. Students, all of you, your display name is just replaced with your roll number. Kindly replace your name with your roll number. So in that way, it should be easy for us to take the attendance of the students. All of you kindly change your name with your roll number. Change your name with your roll number. All of you, all branches students, change your roll number, change your name in your display with your roll number. Some Akhil Rathod, David, Durga Prasad, Harshavardhan, Rishkeshwar, Krishna Reddy. Students, all of you kindly change your display name with your roll number. Replace your name with your roll number. Students, all of you replace your names with your roll number. Harshavardhan, Rishkeshwar, and Krishna Reddy, David, Surya Manikanta. All of you change your name with your roll number. Harshavardhan, Rishkeshwar. What are you doing? David, Durga Prasad. Change your name with your roll number.
Go to the WebEx profile and change your name with your roll number.
Harshavardhan, Durga Prasad, and David. Change your name with your roll number. Pratima, change your roll number. Ranganaik, Sivaram, Surya Manakanta, Upendra. Pavani Umireddy, change your roll number, name with your roll number. Harshavardhan David, Sivaram, Tirumala, Upendra, change your name with roll number. Okay, students. We will start our session now. So, good morning, all of you. So, yesterday we discussed this problem. I think all of you are aware of this problem. A square prism side of base 30 mm and axis 50 mm. Resting with its base on HP and axis is inclined 50 degrees to HP such that it has edge of base in HP and inclined 45 degrees to VP. That means, first of all, let us see, first of all, given axis is inclined to 50 degrees to HP. That means always first you consider the axis inclination. For placing simple position, axis inclined to HP means let us place your axis perpendicular to HP. When your axis is perpendicular to HP, which you use the true shape? Which you use the true shape? So let us see square prism which is going to axis inclined to HP such that one of base edge on HP. So when your axis inclined to HP means in simple position for stage 1, let us put your axis perpendicular to HP. Okay. So top view gives the true shape. So I just draw the top view which is going to be obtained true shape which is a square, and front view you are going to see the height of the solid. So front view I just project my projectors with the height of the axis is 50. I get my stage 1, that is step 1 and 2. Next, what is stage 2? Always consider the axis inclination such that one of the base edge on HP like this. So this base edge is on HP. When you are going to see the front, you just see this point and this point is invisible. So that means R of S is going to be on HP such that I just reconstruct the figure in such a way that it is making some 50 degrees to the HP. I just reconstruct the figure such that R of S is on XY and I just reconstruct the figure. From here, draw the vertical projectors. From here, draw the horizontal projectors and mark the intersection points. So you will obtain your top view. Next, what was up to here, up to this 1, 2, 3, 4, we already did so many problems. Now, what was your stage 3? Solid, resting on HP, axis is inclined such that one of the base edge on HP, the edge which is resting on HP, let us see, this edge is making an angle of some 45 degrees to the VP. So that means now in this position we can say it is inclined to both the reference planes. Okay. So when it is making incline from 45 degrees to the VP, so I just draw a line of 45 degrees. The edge, SR is the edge, is to be on this 45 degrees line, and I reconstruct the figure. Once I reconstruct the figure, now draw the vertical projectors and draw the horizontal projectors and mark the intersection points. Okay, and join all the points, you will obtain the final front view. Okay, students. Okay. Now let us see another problem. All of you write a problem. A hexagonal pyramid hexagonal pyramid. One of its slant edge on the ground. Up to this, we already did the same from hexagonal pyramid side of base such that axis is going to be one of the solid is ground, that is axis inclined to HP. Already do this problem in solid inclined to axis inclined to one reference plane. Now let us see the inclined to second reference plane, how it is. The problem is a plane containing the edge and the axis is perpendicular to HP. Axis is perpendicular to HP and inclined axis is perpendicular to HP and inclined 45 degrees to VP. 45 degrees to the VP. Draw the projections. And when apex is nearer to VP. Apex is nearer to VP. Why some of the people had left just now? Who is that? So students, you just have to remember one thing. If you just participated the session and within 5 minutes if you left, the attendance is not considered. The attendance is not considered. So attendance is considered until you are going to be appeared for complete session. You are appeared for the complete session. Then only your attendance is considered. So because in our database we just obtained. So which roll number is going to be placed, how much of the time in the session is clearly obtained. So we just consider the students who had for the total session, who had attended the total session is considered. So don't left over meanwhile at the middle of the session. Okay. Now let us see the problem. So given which pyramid it is, a hexagonal pyramid. So we already do this kind of problem. So that means one of the slant edge is going to be on the ground. Let us see. So we consider a hexagonal pyramid like this. So this was a pentagonal pyramid. Let us assume this is a hexagonal pyramid. Okay, one of the slant edge is on ground means the axis is inclined to HP. What is the simple position? You just consider axis is perpendicular to HP. That's okay. Now, second stage, you just place your solid in such a way that one of the slant edge on the ground. That's okay. Next, what we just gives the axis is the plane which is going to be consisting the axis is perpendicular to VP and inclined 45 degrees to VP. That means the axis which is going to be considered for this solid is inclined 45 degrees to VP like this. If you place you like this or like this, but the condition he gives is when the apex is nearer to VP. If you incline your solid in this manner, this apex is away from VP. If you consider your solid in this manner, that means your apex is nearer to VP. So you just reconstruct the figure in the final stage like this. Okay, let us see. This was very simple. We already did the first two stages. We already did it. So here it is going to be a hexagonal pyramid. Okay. Now tell me which gives the true shape. Axis is inclined to HP. Let us assume axis perpendicular to HP. Top gives the true shape. Okay. So you can maybe get a doubt. So why your hexagon is going to be in this manner? Why not it should be? Why not it should be like this? Why not it should be like this in simple position? So if it is going to be tilted, then what happens? This edge is going to be comes on the ground. That means triangular face is going to be obtained. When you consider it is a edge resting problem like that, when you tilt it, that means this triangular face is going to be comes on the ground. My requirement is slant edge is only on the ground. For that only, I just construct as a corner resting column. So why? Because corner to apex is going to be slant edge. If I just tilt it, this slant edge comes on ground. For that only, I just consider here. This is not considered. If we consider that edge is going to be on HP and triangular face is going to be obtained on HP, then you can consider this. But in the problem, he just gives slant edge is coming on HP. It is on ground. Okay. So how many set of points you are going to obtain? This was a pyramid. So you are going to obtain only one set of points. So when you are supposed to see from the top, you see that from apex all the corners are going to be joined. So mark the points A1, B1, C1, D1, E1 and F1. So what was the side which is given? Base side is 25. This was step 1 and this was stage 1. So when you are, so this becomes your O1 or O2. And he also gives the height of the axis. What is the height of the axis? He just gives, what was the height of the axis? 60. Okay. And draw the projectors. So when your base is resting on HP means front view comes on XY. The base points all are going to be comes on XY. So for that I just project my projectors up to XY. Mark the invisible points in front view. If you see like this, A, B, C, D are visible, E, F are invisible. So this becomes A1 dash, this becomes B1 dash of F1 dash, this becomes C1 dash of E1 dash, and this becomes D1 dash. So this is your O1 dash and this is O2 dash. Now join all the, so all corner 1, 2, 3, 4 corners are visible. So the lines which are passing from here are going to be solid lines. So this was step 2. Okay. So you see that when you join O with EF and O with E, which are invisible points, those are drawn with dotted lines, but the dotted lines are hid by the OC and OB solid lines. Okay. Always preference gives first for the solid lines, second preference for dotted lines, no preference is given for the axis. Okay. Next, what is the stage 2? Axis is going to be inclination is considered in stage 2. Here axis inclination is given, no. What he gives, one of the slant edge is on ground, that makes your axis inclined to HP. So I just consider my slant edge OD on the ground. Okay. So simply I just consider here, this becomes my O1 dash and this becomes my D2 dash. Let us consider it is some stage 2. I just consider. So let us consider ODA is a triangle. I just reconstruct my figure. I reconstruct the figure in such a way that ODA is going to be your triangle. So I know O and D. So OA has a radius, O has center drawn, DA has radius, D has center drawn, we obtain E dash. Can't we get the remaining points? So this becomes your C2 dash of D2 dash, and this becomes your axis, and this becomes B2 dash of F2 dash. This is some O2 dash. This is step 3. This was stage 2. Okay. Now join the edges. These are the slant edges. Okay. Now when you are supposed to see from the top, you are going to see the bottom base completely visible. When you are supposed to see from the top, this base is completely visible. Now let us see, draw the vertical projectors from here. And horizontals from here. And now mark the intersection points. Okay. So when I am supposed to see bottom base is completely visible, so I just join all points with the solid lines. Why? Because base is completely visible from the top. When one of the slant edge is on ground, okay, so this becomes your O1, this becomes O2. Next condition is join all the corners to the apex. Now let us see, my rule is going to be no two solid lines can cross each other. Solid line and dotted line can cross. Okay. Now if I join A with O, is there any problem? There is no problem because no obstacle is obtained. If I join F with O, let us see, no problem. If I join B with O, no problem. B with O also, you didn't get any problem. Okay. Now if I am supposed to join D with O also, no problem. These two solid lines are going to be coincide. Next, if I join E with O, EO is going not to be solid. Why? Because FA is a solid line. If I draw a solid line, solid lines are going to cross. So no two solid lines can cross. So it should be dotted. Similarly, OC is going to be also dotted line. Why? Because AB is already solid line. If I draw the solid line, two solid lines cannot cross. So it should be dotted. Okay. So this becomes your step 4. Next, what he gives, axis is going to be inclined. Okay. So in such a way that it is to be reconstructed in such a way that axis inclined 45 degrees to the VP. So that means you can make it, draw a line of 45 degrees. Let us see, draw a line of 45 degrees, and you can reconstruct the figure in such a way that axis is going to be tilted in such a way that apex is nearer to VP. So apex is nearer to VP. So that means you can place your, this is some O, O1, and this is some O2. Okay. Once you know 2 points, can we get the remaining points? And O2, here it is going to be A2, and here it is going to be D. So let us consider it is A and D without suffix. Okay. Now you will get your points as B, C, D, E. You are going to obtain your reconstructed figure in such a way that like this here, and you are supposed to join upon this becomes A, B, C, D, E, F. Okay. So after that you just join the points O, F, O, B. Okay, like this becomes your 5th step, and this was stage 3. Okay. Why? Because your apex is nearer to VP, that means it should be nearer to XY. Okay. And from here, you are supposed to draw the vertical projectors. Okay, and from here draw the horizontals. And now mark the intersection points. Mark the intersection points. So let us see. So here it is F and here it is F. You will get that F here. F dash. E dash. D dash. C dash. E dash. A dash. And here it is going to be your O dash. Okay, so when you are supposed to see from here, the bottom base is completely visible. That means when your solid is going to be inclined apex nearer to VP like this, so when you are supposed to see from the front, the bottom base is completely visible. So I am supposed to join all the corners. Okay, and if you are supposed to see, here it is going to be your okay. Now I am what I am condition is join all the corners of the base to the apex. So F with O, no problem. E with O, no problem. D with O also no problem. Now if I am supposed to join A with O, then solid lines are going to be cannot cross each other, so it becomes dotted. Similarly, B is also dotted and C is also dotted. Okay, so this becomes your step 6. Okay, students, is it clear? Sixth step, which is very easy. Sixth step, what we did in this third and fourth. So third step, you just draw the vertical projectors and horizontal projectors to obtain here. So fifth is already obtained. From fifth, I draw the vertical projectors, and from three, draw the horizontal projectors. Now mark the intersection points. After marking intersection points, so how can we join this? So this is nothing but your final front view, right? This was your final front view. This was your final top view. So always you just see that how you are supposed to see the front. That means if you see in this manner, that becomes your front view, which already we do like I said here. That means when your solid is going, axis is making 45 degrees to VP means it should be like this or it should be like this. But condition given is apex is nearer to VP. That means in this manner. If your solid is in this manner, when you are supposed to see from the front, you see this base is completely visible. So further down, if I see from this manner, the base is completely visible. Okay. So further down, I join all this base with the solid lines. Why? Because it is completely visible. Now, here it is my O dash. Once I obtain all the corners of the base, I am supposed to join all the corners to the apex. Now I take my principle, no two solid lines can cross each other. That was my principle. So I joined F with O. I didn't get any problem. Straight line, solid line. E with O, no problem. D with O, no problem. Now, if I join A with O as a solid line, here FE is a solid line, it can bisect. No, it should not to be done. Why? Because no two solid lines can cross. So then I just change it to dotted line. Similarly, B with O is to be joined. If I draw the solid line, these two are also going to get crossed. So I didn't do that. So again, B with O is also dotted line. Similarly, C with O, it is also dotted line. Why? Because ED is going to be the solid line. Okay. Now O2 dash is and O dash is going to be your axis. Okay, students, is it clear now? So we can do this problem in auxiliary method also. Shall we do that? Let us see. So axis is inclined to 45 degrees means simply what should I do? I just extend my axis. I just remove the problem here. So problem is already you just noted down. I just remove the problem for my construction of auxiliary method. You just see how can we do in auxiliary method also. Simply, so this was your final painting. This was final copy, that's okay. Now, auxiliary method means how many steps you are going to obtain? 5 steps. What are they? 4 and 5 are my final steps. In auxiliary method, 4th and 5th are final steps, right? So now already I've my final top view in auxiliary method. So how can I obtain my final front view? We just give same by this I just draw the line of 45 degrees. Now this becomes my new reference line x1 y1. That becomes my new reference line x1 y1. Now let us see. What I should do is let us draw the perpendicular projectors for x1 y1. That is new reference line x1 y1 from all the points in the final top view. What is the final top view? Here is your final top view. I just draw the perpendiculars for new reference line x1 y1. Let us see. From here, I just draw the perpendicular from F. Wait a second. Until now, I just take a pic. Okay. I just draw the perpendicular for here and from here, from here. From here. Okay. So from all the points, I draw the perpendicular projectors for the new reference line x1 y1. Okay. And I place the what I am supposed to place? My front view to be obtained. How can we obtain my front view? From the new reference line xy11, take the previous front view. Previous front view is third step. Okay. So take the distances of all the points from the old reference line and put it from the new reference line. So okay, let us see this. Let us see, first of all, this D point is going to be on D2 dash. In third step, this was the front view. So fifth step is going to be become my final front view. What is our reference is? This front view is our previous front view means this is our reference. Take your D2 dash point, so which is on XY. Now let us take the D projector. So D point is also on new reference line X1, Y1. Now let us see C point. C point is going to be some distance from here to here. This distance is taken as radius. And now take the C projector and mark the point as this becomes your C dash. Similarly, E is also with the same distance from the old reference line XY, this radius. I just take again E is my projector. So this becomes my E dash. Similarly, O2 dash. So O2 dash is also some distance away. So I just draw the, so this becomes O2 dash. And similarly, O1 dash is also, O1 is also on old reference and XY. See, this becomes my O1 dash. Next, B and F are also some distance away from the, some distance of height from the old reference line X1. I just take this radius and I just take these projectors B and F. So this was my B projector and I place my point at somewhere right here. This becomes, this was the B projector, so this becomes B dash. With same radius, I just consider my F dash projector. This becomes F dash. And next one is A. Let us take your A projector. So which is it here? This becomes my A dash. So okay. So in this manner, how can we see this? How can we see which points are visible, sir? Let us see. Always your observer is perpendicular to XY. Similarly, if it is becomes your new reference in XY1, your observer is going to be perpendicular to new reference in X1, Y1. Now, if it is perpendicular in this manner, you are supposed to see the total base, right? If it is going to be seen this way, total base is visible. So I just consider all points are going to be the visible points. So I just join all those points. Okay. Now I'm supposed to join our condition. We already know that what was our condition? All the corners of the apex to be joined to the and all the corners of the base are going to be joined to the apex with the help of slant edges. So that I just know the condition is no two solid lines can cross. So I join excuse me B dash with O dash. Next, if I join, so this becomes your C dash. C dash with O dash. D dash with O dash. And if I join E dash with O dash as a solid line, this was solid line, this was solid line. So this becomes dotted line. Similarly, E. So this becomes my fifth step. This becomes my final front view. And this becomes my final top view in auxiliary method. So this becomes, this is change of position method. Change of position CPM, change of position method. And this is auxiliary method. Okay. Students, is it clear? So in this auxiliary method, fourth and fifth steps are going to be my final steps. Fourth and fifth are going to be my final steps. Okay, students, I just give you some 2 minutes time. You just copy it. Students, had you all understand the problem? Had you all understand step-by-step process difference between the change of position and auxiliary method? So 5 and 6 steps are obtained. That was change of position method. When you consider for the auxiliary method, you require only 4th and 5th step. So 4th step, which is already obtained in stage 2, that is, and I obtain my final front view. Okay. Now on the bottom of the figure, all of you had to mention all dimensions in make it fast. Students, have you copied the problem? Shall we move to the next problem? So in the auxiliary method, the final front view, I just forgotten to join the axis also. Let us see, your axis is O2 dash. So this was O2 dash, O1 dash is going to be your axis. So what is the axis? Which is the line joining the center of the base to the apex. What's it? Someone had placed a message. What is that? From the starter, we have drawn the drawings. Mentioned. Yes, very good. Very good. No problem. In the notebook also, that's not a problem. So for next class, you just go over with the No problem. If it is not with in notebook, that's okay. So if it is not possible, if you have placed in a short notebook, then you just go for A4 sheets. That's also. Whatever the convenient way that you are supposed to construct, you just follow it. But we just want the total columns which we discuss. It should be in the original dimensions. If it possible in notebook also, that's okay. If not, you should do it with A4 paper or legal paper. Then it should be easy for you. Saujanya, can you just type your roll number in place of your name? Saujanya B, Durga Prasad, Sivaram, Stalin Martin. Just replace your name with your roll number. Okay, students, shall I erase this? Shall I erase this problem? Is it okay? Shall I erase this problem? Okay, I am erasing this problem. Thank you. Students, in the examination point of view, you can follow any of the method, that is change of position or auxiliary method, unless he mentioned in the problem. If he mentioned do the problem in change of position method, then you have to go for 6-step procedure only. If he asks you to do it in auxiliary method, you just go for the 5-step procedure. If he didn't ask any of the method, either auxiliary or change of position method, you can go with your easier method. If your 5-step procedure is easy for you, you can go for it. So if not, the 6-step is okay, sir, then you go for 6-step. So unless if he mentioned it is either change of position or auxiliary method, you have to go for it. Okay, if not, you can do it of any method. Okay. Next, write another problem. A pentagonal prism is resting on one of the corners. Pentagonal prism resting on one of its corners of its base on HP, of its base on HP. The longer edge containing a corner, the longer edge containing that corner is inclined at 45 degrees to HP. Is inclined 45 degrees to HP. Okay, students, a pentagonal prism is given resting on one of its corners of its base on HP. The longer edge containing that corner is inclined 45 degrees to HP. Axis of prism makes an angle of axis of prism makes an angle of 30 degrees to the VP. Makes an angle of 30 degrees to the VP. Draw the projections of the solid. Draw the projections of solid. Another bit is that was the first bit. Also draw projection of solid. Also draw the projection of solid when the plan of the axis, when the plan of the axis inclined 30 degrees to XY, okay, inclined 30 degrees to XY. Next, base side is 30 mm and height of the solid is 70. Base is base side. Base side is 30 mm. Height of solid is given 70 mm. Very important problem. So this was a kind of which we already did it in the planes also. So directly he is supposed to consider the inclination is going to be one procedure and plan of the axis. Plan means top view. Always you just consider elevation is nothing but front view. Elevation means, just remember this. Elevation means front view and the plan is nothing but top view. Don't get confused. So also when the plan of the axis is inclined 30 degrees to XY, that is, in this problem you are going to obtain 8 steps. Why? Because this was the problem in such a way that it is going to be the diagonal problem. Okay, so why? Because we are supposed to find the apparent angle beta. Okay, and also we are supposed to construct from the directly 30 degrees to VP. Okay, and also we are supposed to find the apparent angle and we just reconstruct the figure on the apparent angle. So that is the consideration in this problem. Why? Because why we are supposed to find the apparent angle, sir? What is the need? How can we know it, sir, to find the apparent angle? Yes. Whenever it is a corner resting problem, we already discussed in projection of planes and also simple position of the solids. Whenever your corner resting problem is going to be seen or diameter or diagonal is seen, then you have to find the apparent angle. Here you are going to see that resting on one of its corners. When you see this corner resting problem means you have to find the apparent angle. Okay. So further we just construct apparent angle and then reconstruct the figure. So this means also when the plan of the axis is inclined means Without finding the apparent angle, you can construct it. That is also second step. So for this problem, you are going to obtain 8 steps in change of position. Okay, now let us see how can we do this problem. That's fine. So here, first of all, axis inclination is given. So let us see if the problem he just make you confused. First inclination is based on HP longer edge contain corner incline 45 degrees to VP. So whenever you simply see 45 degrees to VP, okay. So here it is 45 degrees to VP means let us place your axis perpendicular to VP. Then it is completely wrong. What he gives the longer edge containing that corner. Okay. The longer edge containing that corner is going to be making inclination. That means if it is a pentagonal prism, resting with one of its corners, let us see one of the corners it is resting, and the longer edge consisting that corner is inclined. So this means like this. Okay. Next, axis of the prism is inclined for 30 degrees to VP. So this was the consideration first we had to consider. That means always we had to consider the containing that corner is inclined. Yes. So I just confused. Let us see. First of all, containing that corner, longer edge containing that corner is inclined. How many degrees? It is 45 degrees to HP. Yeah, all of you just to see this. So very easy to understand. I just confused. Let us see. If it is the solid resting on one of its corner, and if it is tilted means this a longer edge is making inclination means what we can say this total solid is going to get inclined. Whenever total solid is inclined means that the axis is also get inclined. Okay, so further only we can directly consider axis is perpendicular to HP. Don't go for axis of prism makes an angle of 30 degrees to VP directly. First of all, why? Because longer edge containing that corner is inclined means now total axis is also inclined like this. That means total solid is inclined. That means axis also inclined. So first we have to consider this. After that, the axis is inclined. Axis inclined 30 degrees to VP like this. Simple position, resting with corner, and then the axis inclination. First stage, second stage, and third stage. Students, okay? Simple position, second stage, simple position, first stage one. Second stage, axis inclination. Next, another inclination. So these were the 3 steps. Okay, students, now let us see. So now, which is going to be our initial stage to follow? Which view gives a true shape? Axis perpendicular to HP. Top view gives the true shape. Okay. A1, B1, C1, D1, E1. What was the side? Side is given as side 30. So this is a prism. How many set of points you are going top base and bottom base? You are going 2 set of points. So that means in bracket it is P1, Q1, R1, S1, T1. Now let us place the center. So this becomes your center, and this becomes your. From the center, you just draw the vertical to obtain axis. This becomes O1 of O2. What was the height of the axis? He just gives 70. height of the axis is 70. Now it is a prism, so bottom base points that comes on XY, top base point comes on this 70 height. Okay, so for that only I just draw the projectors. Okay, now mark the points. What are the top base points? Which are visible points, which are from top to ABC are visible. So while coming from the front, ABCD comes on the top. So this becomes B1 dash of A1 dash. Simply if you are supposed to see the top means this was step 1, stage 1. A, B, C, D, E are going to be appearing on top base. So while you are going to see from the front, B, C, D are visible. So this becomes C1 dash of E1 dash, and this becomes D1 dash. Okay. Okay. So these three corners are visible. Visible corners, the lines which are passing from the visible corners are going to be the solid lines. Okay. So this becomes O1 dash. This becomes O2. This becomes your step 2. Okay. What was our stage 2? That is step 2. Longer edge containing that corner. Longer edge containing that corner is inclined 45 degrees to HP. So HP inclination comes above XY. Longer edge containing that corner is DS is your longer edge containing that corner. So that is going to be making an angle of 45 degrees. That means this edge is making 45 degrees. So draw a line of 45 degrees. So in such a way that you this bottom points, let us place this bottom points also. So this becomes Q1 dash of P1 dash. This becomes R1 dash of T1 dash. This becomes S1 dash. Now S dash D dash is on. S dash D dash on. This becomes S2 dash. This becomes D2 dash. Okay. So this becomes your Q1 dash of P1 dash. So here it is R1 dash of P1 dash, and here it is your axis. Okay. So these points are going to become, this becomes B2 dash of A2 dash, this is O1 dash, C2 dash of E2 dash. Okay. Now this becomes your third step. So when you are supposed to see from this view, this base is completely visible. Now let us see what is going to happen. So draw the vertical projectors from here. Horizontals from here. from all the intersection points. So this becomes your, let's take this is P2. Okay, so this be P2. P2, P2, R2, P2, S2. Similarly, it is A2, B2, C2, B2, E2. So when you are supposed to see from the top, this top base is completely visible. So I just join all the points with the solid lines. Okay, and from here, let us take the farthest point is going to be S2. From here, farthest point is S2. I just go for the principle. For lines which are passing from the farthest point are going to be the dotted lines. So here S is going to be the farthest. So I just consider the lines which are passing from S are going to be dotted. So remaining I just go for the solid. Okay, now I'm supposed to join all the consecutive points, that is AP, BQ, CR, DS, ET. All are going to be just joined. Now let us see P with E. Is there any problem? I just go for the solid line. There was no problem. P with A, let us go for it. I just go for the solid line. There was also no problem. Why? Because solid line, dotted line can cross. Now again I go for Q with B. No problem. Why? Because solid and dotted line can cross. Now again go for R with C. No problem. Now if I am supposed to join S, S is going to be the farthest point. Lines passing from S are going to be the dotted. And from this solid and dotted can cross each other. So this becomes your O2. This becomes your O1. So axis line is to be represented up to here, because here also axis is existed, but it is covered by the dotted line. Okay, so this becomes your fourth step, and this is stage 2. Students, is it clear up to now? Students, is it clear up to now? Next one is we are supposed to find the corner problem, corner resting problem. We have to find the apparent angle beta. So why it is making 30 degrees to VP. Okay, if it is making 30 degrees, so we are supposed to find the apparent angle. Okay, how can we find the apparent angle? Let us see. This was very simple. So first of all, draw for the given inclination 30 degrees to VP. I just draw a line of 30 degrees. I just draw a line of 30 degrees. I just make my point at some O1. Now I just take my O1, O2, initial height of the solid. O1, O2 as going to be radius. O1, O2 height of the solid. Okay, and I go for draw an arc on this 30 degrees. This becomes your O2, and draw a line passing through O2. That becomes the locus of O2 now. Now take the reduced axis length, which is obtained on fourth step. That is, height of the solid is going to be Reduce. Why? Because when your axis is going to be inclined means in one view you are going to obtain reduced length. So let us take this axis height, that is O1, O2 in fourth step. Again O1 as center, draw an arc at here, so drawing this with here, and you will obtain with the horizontal is beta. With the horizontal is beta. Okay, students. Okay. Now we just obtain your beta. Now construct the figure in such a way that it is to be on beta. Okay. So that was the one thing. And another one is directly when the plan of the axis is given. Plan of the axis is given means the top view of the axis inclined means directly this top view is going to be inclined. Directly the top view is going to be inclined. That means so directly on the 30 degrees line you just reconstruct the figure. Directly on 30 degrees. Okay. So let us see. First of all, that is all of you just note how can you obtain your beta. Then you just measure it and you just place separately. Once you know your value beta, then you just draw a line of beta and you can reconstruct it. Okay. Now first of all, I just take a line of beta. Draw a line of beta. The procedure is same. Either you find out the apparent angle beta, you reconstruct the figure on beta. So second stage is without finding beta, draw a line of 30 degrees and you reconstruct the figure. This was first bit. That means nothing but the corner that is resting means directly we find beta and we reconstruct the figure on beta. Second bit is also drawn when plan means so directly you just go for on 30 degrees without finding beta. Okay. Now let us see what we should we do. I just draw a line of beta. I am supposed to reconstruct the figure in such a way that either you should reconstruct in this manner or you can reconstruct in this manner. That's your choice. First of all, I just place my this is O2 and this is O1. Okay. So all these points you are going to be obtained. This was D and this was S. Okay. Now mark the points. So once we have your 4 points, can we get the remaining points for this pentagon and this pentagon? Let us consider this top pentagon. So D. Students, is it visible? So I just lost my power, lost the power in my home. So it was a cloudy environment here. The sunlight is very poor. I'm just trying out. Wait a second. Wait a second. Just wait a second. I just on the generator. Wait a second. Just wait a second. Wait a while. Yeah, it's okay now. Okay now? Okay, right? Rajan, Marchu. Okay, it was clear now? Okay, we just proceed. Fourth figure on this step. That is nothing but your change of position. The position is going to be changed to beta. So beta is nothing but your axis is going to be making inclination to axis of the prism. That means axis making 30 degrees to be such that only I place O1, O2 on this. Okay, so this was going to be your axis line. Not a straight line, it was an axis line. Okay, now mark the remaining points. All of you just do it. Line of beta. Okay, and I just place my O1, O2. This was B. A, B, C, D. Okay, similarly, I obtain this is my S, P, Q, P, Q, R. Okay, and I'm supposed to join ST, AP, BT, PQ. Okay, don't get confused. The lines which are passing from S are going to be the dotted. So this becomes your fifth step. Okay, so this becomes your final top view. Now, when you are supposed to see from this front view, so this base is completely visible, right? When it is inclined like this, if you are going to be seen from this means this base is completely visible, this is invisible. Okay, how you taken the farthest point is the, that is going to be the lines which are passing from D are going to be the dotted. Now let us see, draw the vertical projectors from here. Similarly, draw the vertical projectors from all the corners and draw the horizontals from the previous front view. Okay. Now mark the intersection points. Let us go for the ABCD first here. ABCD. Mark the intersection points. This was A dash, B, B dash, C, C dash, D, D dash, E dash. Similarly, place the bottom points. So here it is T, QP. Let us take QP, and these are PQ. This becomes P dash. Q dash. Next, R, R dash, E dash. This becomes S dash. Okay. Now, while you are supposed to see from this base is completely visible. So this is joined with the solid line. Next farthest point is going to be considered some D. The lines which are passing from D are going to be the dotted, and remaining I just go for the solid. So if you go for the original construction, you will get the exact shape of a pentagon. Okay. So DS is going to be joined with the dotted line. So E with T, E with T is going to be not a problem. P with A, B with Q, and also R with C, will obtain R with C. So like this, you will obtain a pentagon like this. I just make a mistake at somewhere. I get my shape awkward. You just do somewhere original construction. This top is going to be obtained clearly, but in front view it makes some mistake. I just misplace the points. I think misplaced points are taken place. Okay, so this becomes your final front view. You just understand the concept, right? That's okay. So you will obtain your axis at somewhere at here. O1 dash, O2 dash. That becomes your axis. Students, is it clear? The procedure is going to be same, but I just have some mistake in construction of or placing column. So the shape just get changed. But the procedure is going to be as like this. Okay, is it clear? Students, is it clear? So next you just know another method like, so that is, you just do the same procedure here I constructed for beta. You just do the same procedure for taking an angle of 30 degrees and directly do the procedure. So this becomes your 7th and here you will get 8th. Okay. So this was our first step only. That was in the problem, that is 5 and 6. In fourth stage, you are going to apply, this was stage 3 generally. So stage 4 is this, that is nothing but 7 and 8. 7 and 8 are going to be obtained by taking an angle of 30 degrees, directly reconstruct the obtained top view on this 30 degrees. Okay. Okay, students, understand what the 30 degrees line? In the second point, he just gives the plan of the view. That means top view is making an angle of 30 degrees to XY. So obtain the top view. That is step 4 is directly reconstructed on the 30 degrees. Okay, students, is it clear? Shall we move to the next problem? Shall I erase this? Can I erase this column? Okay, take another 2 minutes, no problem. Just take 2 minutes. Make it fast. So this problem is going to be directly constructed as an example in NDB textbook, problem 13.25, the same problem. Problem number 13.25. NDB textbook, problem number 13.25. Okay? And also you have to do the, all of you just take the problems. 13.19, 13.18. You just have to see the problems. 13.18, problem number 13.19, 13.20. All of you just mark these points. Problem numbers 13.18, 13.19, 13.20, 13.21, 13.22, 13.23, 13.23, 13.25, okay, 13.25, 13.31, 13.31, 13.25 and 13.31. Those problems you had to look over. Okay. Now can I erase this? Can I erase this problem? So somebody had put their thumbs down. So they say this problem is a solved example in textbook, that is 13.19. You just go through 13.19 or 13.21. You just go through the textbook. Solved example. NDB textbook 13.21 or something. Write a problem. A square pyramid, base side 30 mm, square pyramid, base side 30 mm and height 60 mm. He is freely suspended from one of the corners. He is freely suspended from one of the corners. If you have the textbook, you can open it and you can look over the problem also. We have the textbook. This was the textbook example problem. One of the corners of the base. That is problem number 13.21. The problem which we are discussing now is 13.21. Freely suspended from one of the corners of its base. Okay, wait a second. Freely suspended from one of the corners of its base. Draw its projections when the axis has a vertical plane. When axis has a vertical plane makes an angle of 45 degrees with VP. Okay. Now he just gives a very important point for this to solve. When a pyramid is suspended freely from a corner, of its base, comma, the imaginary line joining that corner with the center of gravity of the pyramid will be vertical. This was the point to remember to do the problem. All of you just read the problem carefully. That square pyramid, base 30 mm side and height 60 mm, is freely suspended from one of the corners of its base. Draw its projections when axis has a vertical plane makes an angle of 45 degrees with the VP. So first of all, we just had to consider the square pyramid first. Let us consider the square pyramid. So first of all, always we just consider the axis inclination. Okay. So, but here he doesn't give the axis inclination, but he did draw when axis of a vertical plane makes an angle of, not the solid, axis of vertical plane makes an angle of 45 degrees with VP. In first bit, he just gives it is freely suspended from one of the corners directly is given. Let us take a square pyramid like that. So freely suspended from one of the corners. That means I just tag one of the corner and I just make it freely suspended like this. I just pick it one of the corner of its base and it is freely suspended from one of the corners. When it is freely suspended from one of the corners of its base, now its solid axis is inclined to which reference plane? Solid axis inclined to which reference plane? Inclined to HP. Okay, inclined to HP. So when your axis is inclined to HP means in simple position, let us place your axis of the solid perpendicular to HP. Got it, students? When the solid is freely suspended from one of the corners like this, when it is freely suspended like this, so the total solid axis is making inclination with the HP. So simple position, let us place your axis of the solid perpendicular to HP. It gives the true shape. Okay. Next, after this, he just gives the axis as a vertical plane. So from the vertical plane, the axis of the vertical plane is making an angle of first it is initially it is freely suspended like this. It is freely suspended like this. After that, the axis is going to be rotated for the vertical axis is going to be making an angle of 45 degrees with the VP. So first of all, simple position is going to be like this, and then it is freely suspended, and then axis is going to be rotated. Okay. So in that manner, our first step is to draw the true shape and size. So for our top, we use the true shape and size. Okay. So this was A1, B1, C1, D1. Given side is given of 30. So this was a pyramid. So all the corners are going to be joined to the apex from top. This becomes O1 of O2. So from here, I just draw my axis. Height of the axis is given as height of the 60. Okay. So pyramid having only one bottom base. When it is resting on HP means front view comes on XY. So draw the projectors up to XY. So if it is a prism, one base comes on the height of the axis and one base comes on XY. Here it is a pyramid, so it comes on XY. Front view comes on. So let us see what are the points. This was step 1, stage 1, and tell me what are the visible points from the front. BC are visible, so this becomes B1 dash of A1 dash. Similarly, this becomes C1 dash of B1 dash. This is O1 dash. This is O2 dash. Okay. Here you are going to obtain your stage 1, and this is your step 2. Next one is, did he give the axis inclination? No. He just gives that it is freely suspended from one of the corner. So that means whenever it is freely suspended from one of the corners, the imaginary line joining the corner with the center of gravity of the pyramid will be vertical. So let us consider the center of gravity of the pyramid is going to be based on some h by 3 height. That is somewhere at here. This was some g. Okay. Now I just consider corner is going to be my corner is going to be students. We did a mistake. Anyone can tell me what is the mistake? Anyone tell me I make a mistake. Tell me what is the mistake? Students, I just make a mistake. Can you tell me anyone? I just place a mistake in simple position, a blunder mistake. What is that? Anyone can raise it? Inverted. Next. Yes, pyramid is placed on one of the corners, but I just consider it as edge resting. It is not an edge problem. It is a corner resting problem. Why? Because it is freely suspended from one of the corners. So these are the kind of mistakes. So I just know it's a square pyramid directly. I just go for a square pyramid, but you just have to go for problem clearly. For that only, I just write the given data for every problem. So in this space is not sufficient. I am not writing the given data. Actually, you just have to write the given data, and you came to know you can write about it is a edge resting or a corner resting. By basing on it, you go for it. So I didn't write the given data, and I just simply blindly I just go for a square pyramid which is as like as edge resting. If you do the like this means you will get 0. So for that only you just have to concentrate on the given data also. So this was very blunder which I did. So don't you also just take it as a warning and don't do like this. Okay, so don't confuse. It is a square pyramid. So directly I am not supposed to go for square pyramid. Why? Because it is suspended freely from one of the corner. So it is a corner resting problem. XY. So for corner resting problem means it is going to be equally inclined for an angle of 45 degrees, or it should look like as a rhombus. So given axis is going to be it is 60. Okay, so this was step 1, stage 1, and when you are going to see from the front, you can notice given this height is given as 30. Okay, from here draw the vertical projectors from here to here. Okay, so when you are supposed to see from here, A, B, C corners are visible, and the lines which are visible corners, if you just going for drawing the, so this is nothing but your O1 dash. Okay, so lines where corners are going to be visible means the lines which are passing from apex are also going to be visible. So this becomes your A1 dash. This becomes B1 dash of D1 dash. This becomes C1 dash. So this is the solid line. This is the solid line, and here it also solid line. Why? Because this B corner is visible, apex to the B is going to be solid, but the D is invisible, so which is going to be came at the same point. So here it is also dotted line, but is hide by the solid line, and axis is going to be least preference, but axis is existed. So for that I just mentioned it is O1 dash and O2 dash. Axis also going to be get hide by this solid visible solid outline. So this becomes my step 2. Students, is it clear now? And you understand the difference between the previous stage and this stage? So this was the corner resting problem. So we have to start from the corner. Okay. So and it is going to be visible corners are A, B, C, and the lines which are passing from apex to all the corners are going to be solid lines. So D is going to be imaginary line, but it was hide by the OB solid edge. Next, I know that there is suspended the imaginary line joining the corner with the center of gravity of pyramid will be vertical. Okay, so let us see the center of gravity is going to be situated somewhere at h by 3. So let us consider the triangle. Center of gravity is going to be at h by 3. Okay, so taking from the apex or 1 by 3 from the base. Okay, and let us consider my corner is going to be A dash. Now my imaginary line joining. So when you are supposed to make your solid is freely suspended means you just have to know that the imaginary line joining the corner to the center of gravity is going to be vertical. That line becomes vertical. That means this AG becomes vertical. Students, have you understand the condition? When pyramid is freely suspended from one of the corner of its base, the imaginary line joining that corner with CG of pyramid will be vertical. Now I just consider my corner is A and center of gravity is G. If I just join the line A dash with G, so if I am supposed to make it freely suspended means this AG line becomes vertical. That was the condition I know. So further directly I just make my line AG vertical first. Let us see. I know this AG line is vertical. So this is A2 dash and this becomes G. AG line becomes vertical. Okay, and you can see this. Now let us consider simply. Let us consider AGO is a triangle. AGO is a triangle. Why? Because I know these 2 points only. A to G is going to become vertical. Now I become AGO is a triangle. I know already 2 points. Can I get my third point? Can I get my third point right? Yes, we can get our third point as, so here it is going to be G as center, GO as radius. Similarly, K as center, E as radius, you will obtain some O1 dash. You will obtain some O1 dash. Now find G with O and A with O. D with O and A with O. And I know that G, B are going to be lies on the same line. Now you see, O, G, B lies on the same straight line. So I extend OG to some extent. I extend OG to some extent and I take GB dash as radius. GB dash as radius. Okay. GB dash as radius. Draw an arc. So this becomes B2 dash of D2 dash. Now I know that if I know my B dash, A dash, B dash can join. I join A dash with B dash. And you can see that A dash, B dash, C dash lies on the straight line. So I extend my A dash, B dash to some extent. Okay. And I take A dash, C dash as radius, A dash as center, try to obtain my C2 dash. Once I obtain my C2 dash, now I join C dash with O dash. C dash with O dash. Okay. And I know that these two are going to be perpendicular and this was going to be perpendicular. Students, is it clear? Is it clear to reconstruct the field such a way that A to G is going to be vertical? Can I explain once again? Can I explain once again the reconstruction of step 3? Okay, let's see. This was step 3. Let us see. I just do it again once. I just do it separately. First of all, I know the condition is imaginary line joining the corner with the center of gravity of the pyramid will be vertical when the pyramid is freely suspended from one of the corner. So I just consider A is going to be the freely suspended corner, and I place my point G on the G is nothing but your center of gravity G, and I join A with G. I join A with G. Now, first of all, I know this AG becomes vertical. So first of all, I just draw a line. This becomes A1. This becomes G. Once I know AG, let us see AGO is a triangle. Simply, I just reconstructing the figure by having 2 points. I am going to get third point. Let us see. AGO is a triangle. I know already AG, which is going to be a straight line. Why? Because will be vertical. So in this condition, I just take the straight vertical line. Now, A as center, AO as radius, draw an arc. A as center, AO as radius, draw an arc. G as center, GO as radius, cut the arc. G as center, GO as radius, cut the arc to obtain your O1 dash. Once you obtain your O1 dash, now you can join G dash with O dash and A dash with O dash. Next, you know that, let us see. OGB lies on straight line. OGB lies on straight line. So for that only I just extend OG to some distance. Extend OG to some distance, and I take G as center, GB dash as radius. This was the radius. GB as radius, G as center, draw. This becomes your B dash of some D1 dash. So it is 2. I just take it as suffix 2. Now join A dash with B dash. Okay, now I know that A, B, C lies on straight line. So A, B and C must lie on straight line. So I extend my point to some extent. Next I know A dash as center, A dash C dash as radius, A dash as center, A dash C dash as radius. Draw an arc to obtain C dash. Once you obtain your C dash, now join C dash with O dash. Now join C dash with O dash. Students, is it clear now? Okay. For your convenience, you just see this. This AG becomes vertical. First, I just consider this, and I then reconstruct the remaining thing. Okay. Now this becomes your cursor. When you are supposed to obtain your top view, okay. So when you are supposed to see from the top, you can see all the base points are completely visible. Okay. So draw the verticals from here. Horizontals from here. And now mark the intersection points. So this is D2, A2, B2, C2, this is O1, O2. So while you are going to see from the top, base is completely visible. So I join all the base edges with the solid lines. Solid lines means visible outline, visible solid lines. Now let us join all the corners to the apex. Let us see, is there any problem for us? O with D. If I join O with D, no problem. Join B with C. Sorry, B with O. No problem. And join A with O. Okay, no problem. And one more point you just see here, if I going to be like this, I just you just had to place the points. Let us see. So this becomes your, this is C2, this is A2. Okay, one more point you just had to, if I'm taking my solid is going to make inclination like this. When I see from the top, I just going to see the base points and I see 1, 2, 3 corners and the slant edges which are passing from apex to these 3 corners are noted, but this bottom is going to be bottom slant edges seen from top, it is not seen. Okay, so let us see that bottom point is going to be your, let us see if it is going to be like this, A, D, C, and it is going to be your B. Okay. So furtherly, when you are going to be seen in this manner, okay, like this. Why? Because when you are going to seeing from this top, when you are supposed to seeing from this top, you are going to see the 1, 2, 3 corners, and these are slant edges, and base is completely visible, and this solid edge is going to be not seen from C. Okay, for that only I just construct here. Okay, so this becomes your step 4 and stage 2. And when you are going to see from here, this was the bottom point. C is going to be the, when you are seeing from the C is going to be the bottom point. For your convenience, you can make it as going to be like this, up to here. Is it okay, students, up to here? Okay. Okay, now, so after that, projector when acts as a vertical plane makes an angle of 45 degrees with the VP. So that means axis is going to be tilted for an angle of 45 degrees. So either with VP. So he didn't give the apex is neither to VP, apex is away from the VP. I don't know. He didn't give anything. So do that angle making an angle 45 degrees with VP such that apex is nearer to VP. So you can reconstruct the figure in this manner, or in this manner. Reconstruct in this, or you can tilt like this. Okay. Now I just do the procedure for apex is nearer to VP. This was simple. I just go for it. It is draw a line of 45 degrees with VP. Okay. Such that the axis is going to be on this 45 degrees. This becomes your O1 and this becomes your O2. And the same points you are going to obtain. This is C and this is A. And you see that DOB lies on the same line which is perpendicular to here. So if I draw the perpendicular from here, I just obtain my points. So this becomes your A, B, C, D. Okay. So this becomes my fifth step, and this is stage 3. This is my final top view. And when you are supposed to see the solid front view, when I am supposed to reconstruct the figure in such a way that axis is making 45 degrees, okay? And when you are supposed to see the front view, so that means if you are going to be viewing in this manner, that means always your observer should be perpendicular to XY. Okay, while you see in the previous auxiliary method also, you just do it. Here also we can do the auxiliary method. How can you do the auxiliary method here? You simply extend this axis and draw a line of 45 degrees. This becomes your new reference line x1 y1, and you can also construct in this manner. And also you can construct in this manner. And here, if it is going to be the pattern, if it is x1 y1, where your observer is going to be perpendicular to the new reference line x1 y1. That means if it is going to be your reference line x1 y1, observer is perpendicular to this, and he is going to be seeing in this manner. Similarly, if it is in change of position method, observer is also going to be at here, which is perpendicular to xy. Now let us draw the vertical projectors from here. Okay, and draw the horizontals from the previous front view. And now mark the intersection points. So if you consider an auxiliary, so then it is going to be your, this becomes your final top view. Here you will obtain final front view in auxiliary method. So this becomes fourth is final and fifth is going to be considered here. Okay. Now you just mark the intersection points. So this was your O dash. A dash. B dash. C dash. D dash. So when you are supposed to seeing from this pattern, the base is completely visible. So I just draw the okay, and this becomes your O2 dash. Now join all the corners to the apex. So from here it is going to be the dotted. From here also it is going to be dotted. That becomes your axis. So this is your sixth step. So I just did nothing. When I am supposed to see here, top base is completely visible. So base is completely solid line, and obtain my apex, and I am supposed to join all the corners to the apex. So no two solid lines can cross. So here to here, no problem. If I am joined here to here, there was a solid line, so I had to make it dotted. So from here to here also dotted. That is BO and AO are the dotted lines. DO, CO are the solid lines. O dash, O2 dash is going to be the axis line. This becomes your final front view. Students, is it clear? Make it fast. Oh, time it's already 6:30. Okay, I just stopped on today's session. I will just stop now. So tomorrow also we will have the same timing and same session. Tomorrow we will complete the projection of solids, that is axis inclined to both the reference planes. Tomorrow is the last class for the projection of solids, that is axis inclined to both the reference planes. And after that we will start the sections of solids. Okay. Okay, all of you just copy this problem and then you just left off. So all of you kindly, I already. So what the question that someone have raised? Both sides. O2 dash to G distance. O2 dash to G. Someone had asked in the chat box some O2 dash to D distance. That is not which is going to be obtained if you join A dash G. You just measure A dash G distance and you just place it A dash G on the which is going to be vertical, that is perpendicular to XY. There is no separate distance for O2G, that is O2G. O2 dash G is not something that is the set. Once you obtain O dash G, you just extend it somewhere. Extend it to some extent, and I know GB, G dash, G to B dash or G to O dash both means the same. Why? Because O, G, B lies on same line. So G as center with this radius, I just draw an arc to obtain this point. C2, A2 should be dotted. Yes, C2, A2 should be dotted. Yes, someone had put that, placed it there. Yes, it was dotted. Any doubts? Anyone? Anyone have any doubt? Anyone having any doubt? What is CG? CG is nothing but the imaginary line you just have to assume to construct. He just gives in the problem when a pyramid is really suspended from one of the corner, the imaginary line joining the corner with the center of gravity of the pyramid will be vertical. For that only, for this statement, I just consider to do this problem. I just consider the center of gravity G, which is placed at a distance of h by 3 from this, or 1 apex, or 1 by 3 from 1 by 3 of its height from the 1 by 3 of the height from the base. So once I obtain this, I just join my corner which is freely suspended is A. So I join AG. Once you take your AG as some x distance, you just place it vertical. Whatever it is measured, you just draw it vertical. Why? Because will be vertical is the condition. Then you just reconstruct the figure. Okay. Yes, G is the centroid of the triangle. Centroid or center of gravity. So centroid means for a plane surface, center of gravity is going to be considered for the solid. Okay. Okay, students. So all of you just kindly go through the textbook and what are the problems which I placed a tick mark for this. So problems number 13 point, exercise 13, 13.21, 13.20. Okay, so 13.1819, so on. Okay, so 13.23. You just go through the problems. Okay, meanwhile, in tomorrow class, we will see another 3 or 4 problems in solids and we just wind off. No, don't use both sides for A4 paper. You just go for a single side. Why? Because means paper is a transparent. Whatever the prints which are going to be drawn with pencil, with HP pencil, it is going to be observed on the back side also. So it spoils the clear visibility of the drawing. So kindly go for it. If you're constructing in paper, one problem, one sheet. Okay. So don't, so you just purchase some 30 or 40 papers with a cost of some 40. Each paper costs, I think, some 60 paise or 70 paise. Okay. You just purchase some 50 papers which cost around 35 rupees. Okay. You just do it like that. Okay. Okay, students, all of you just copy this problem and you can left off. No problem.